Do it. All right, 4.8. Today you are going to learn a whole new group of numbers. Crazy. So, heavy sighs. So when you were little, your teachers taught you the basic numbers, like my little guy Jack, he's in TK, and he's learning 1, 2, 3, 4. You know, they're going through them. It's really cute. I asked him what his favorite number was. He said it was 15. I don't know why, but 15. Well, my favorite number comes from the complex number system. And those are numbers that we don't know just yet. And today, your whole world's going to change because you're going to learn some new numbers. You thought you knew them all. You probably know all the real numbers so far.
All fake numbers.
Now we're going to talk. Yes, we're going to do fake numbers. Like fake news. Exactly. Here we go. We're going to do a little introduction into what a complex number is. All right, so far in your lifetime, you have learned numbers like this. You learned 5. Right? You learned number 5 back in the day, and then you learned probably fractions came next. Like I have half of a pizza, you know, I'm going to share it with 3 of my friends, you know, stuff like that, fractions. And then I believe maybe you learned decimals, because my 5th grader, he's doing decimals, adding and subtracting them. He hasn't gotten to negative numbers yet, or irrational numbers like pi. When did you learn that? 7th grade, 8th grade, maybe. And then you learn square roots, and you learn really ugly numbers. Okay, but what all these numbers have in common is that they're all real. They're all real numbers, all of those. Okay? Today, I'm going to introduce not real numbers, and they're called complex. Now, why in the world would we want to study these, right? I had that asked in my last class, like, why are we doing this? Because these get difficult. When math gets difficult, people want to know why. Why am I doing this, right? Yeah, I get it, and I'll explain that later, but not right now. Okay, so this is what happened. Complex numbers came about because people wanted to solve equations that were unsolvable over the real numbers. They actually wanted to solve cubics, but I'm just going to do this as quadratics because that's what we're studying. So, like this. Can you think of any number that you can plug into there that's going to square, add to 1, and make 0? Any real number, any number that you know of? No, there are no numbers that you know of. So back in the 16th century, in the 1500s, they decided to come up with complex numbers. Okay, so that introduces us to something called the imaginary unit. Now, they're not invisible. People say, oh, invisible numbers? No, they're just imaginary. They're not real. And actually, imaginary, it was a derogatory term. There was a big war over these numbers back in the day. I can tell you all about it. I have the history of mathematics book sitting right up there. All right, the imaginary unit is called I. And that's the way we write it. I know it looks weird with a little tail on the end, but that's the way we write the imaginary number I. Now, what is I? Well, I is the square root of -1. That's what it's equal to. That's something you've never been allowed to do, right? You can't take the square root of a negative number, your teacher says. Yeah, your teacher's wrong. You can take the square root of a negative number, but you don't get a real answer. Now, if we were to take this formula or definition, whatever you want to call it, and let's say we square both sides, I would get I squared equals -1. That right there is key. That is going to be the most key thing that we do today. You've never, ever in your whole life squared a number and got a negative number before out of it. So this is life-changing for you today. Congratulations. Now, if we have any positive number A, and we want to take the square root of -A, okay? We're allowed to do that now. This is what we do. We split this up into -1 times rad A, and we just learned that -1 is I. I is a number. Okay, it looks like a variable, and then we write I rad A. So good. What? Okay, let me show you without variables how this works. Number 1, we're going to simplify. Okay, simplify these mathematical expressions. Here we go. Letter A. What is the square root of -36? Now, you've never been allowed to do that before. You always said, nope, can't do, which is true. You can't do when you're in the real numbers, but you can do when you're in the complex numbers. So this is the same thing as doing this. -1 times rad 36. Do you agree that those are equal? We learned a property this week that said that you can split them up. A times B, square root. Okay, and this, what's the square root of -1? It's I. What's the square root of 36? 6. So the answer is 6I. Now, you do not have to do this thing every single time. If you want to remember, if you take the square root of a negative number, it's going to be the square root with an I put on the end of it, then that's fine. Okay, I have no problem that you think that way. So let's do the square root of -25. What's the answer to the square root of -25? 5I. Perfect. That's it. Yeah. Okay, it's an imaginary number. The square root of -25 is not real. It's 5I is the answer. Let's try another one. Let's do the square root of -100. Good. Yes. And that's some of your girlfriends, right? Yeah. She's a perfect 10, but she's imaginary.
Bobby,
yes. Bobby, square root of -100. All right. ABCD. This is a good one. Yes. My other favorite number would be like what you're going to do next Thursday, talking about Thanksgiving. I overate. Oh, I'm so full, I overate. That's a good one. Thank you. Yeah, that's fake. Okay, here we go. Like these numbers, right? Okay, square root of -8. Now, sometimes we're not going to have perfect squares, but we cannot leave negative numbers inside of our square roots. So you can think of this as -4 times 2. Okay? We want to pull out any perfect squares. What it would be the square root of -4? 2I rad 2. Yeah. If you just did the square root of 8, the square root of 8 is 2 rad 2. But since it's the square root of -8, it's 2I rad 2. Let's try one more. How about the square root of -3? What's that equal to? Square root of -3? This is I rad 3. Okay? Stupid, is that what you just said? All right, so there are things called complex numbers and there are things called imaginary numbers. Complex numbers are exactly like they sound. Complex, right? Yeah, there's a lot going on with complex numbers. Complex numbers look like this. A plus BI. That is the standard form to write a complex number. What this means, those are letters, you're right. What this means, this is the real part, okay? And this over here is the imaginary part. And when you take a real part and add it, or subtract it, whatever, to an imaginary part, they're not like terms. You can't combine them. Let me show you. For example, here is a complex number, 2 plus 3I. That does not make 5I, okay? What that is 2, real number 2, plus imaginary number 3I. When I put those together, it becomes complex. That's what they're called, complex numbers, okay? Another complex number could be -10 minus 7I. That is a complex number. And you always write it in that order. Real part, imaginary part, okay? An imaginary number is going to be a complex number. It's just the real part is 0. So an imaginary number could be 5I or -6I, okay, things like that. That's an imaginary number. But it's also complex too. It's a complex number. So now we have a whole new number system. Are you super excited about this? Yeah. You actually have the complex numbers, and inside the complex numbers are all the other numbers that you've learned. Okay? Real numbers are in there. Complex numbers could be like 3 plus 2I, but you can also have 5 and pi and all those numbers. Those are all in there too. Wow, are you so excited about today? Thank you. Okay, now when you learn new numbers, like for example, when you're a kid and you learn fractions, they're not just going to stop with, okay, you know what a fraction is. No, now they're going to show you how to add fractions and how to multiply fractions and how to divide them, right? When my son learned decimals, now he's adding decimals and subtracting. So that's what we're going to do in part B. We're going to do our operations with complex numbers. So we're going to add, subtract, multiply, and divide them. Are you ready, Nick? Great, let's go. Number 2. Okay, let's add and subtract. We're going to put these together. And we're going to take complex numbers and we're going to add them up and we're going to subtract them from each other and it's going to be super fun. You'll see. Here we go. Let's say I have a complex number. Here's my favorite complex number, 4 minus 3i. It's not my favorite number, but it's my favorite complex number. Yeah, so someone said, what's your favorite number? I'll be like, complex or real? Which one do you want? No? Okay. All right, we're going to take that complex number, and my jokes are really bombing today. Note to self, don't do that one in first period tomorrow. Okay, 4 minus 3i plus 5 minus 6i. Now, my last class, they said, oh, we got a FOIL. There's no foiling here. That's addition, right? I'm adding. So I had someone, they foiled every problem. It took forever. It's so sad. No, we're adding these up, okay? And when you add a complex number to another complex number, you want to take their real parts and add them up, and take their imaginary parts and add them up. I mean, it's that simple. It's exactly what you think you're going to do. So let's do 4 plus 5 is 9. And negative 3i plus negative 6i is negative 9i. And that's it. That's your answer. Okay? So when I take a complex number and I add another complex number, I got a complex number there. No, not with adding and subtracting. Adding and subtracting is the easy one. There's a catch coming up, though. You're right. You're like, this is too easy. I heard this lesson was horrible. How about 5 plus 2i minus 4 minus 3i? Now, subtraction is always harder than addition for a lot of people, for most people, especially in a problem like this. Now, you have to remember you're subtracting all of the parts, okay? I'm subtracting the real part. I'm subtracting 5 minus 4, and I get 1. Then I'm subtracting 2i minus negative 3i. What do I get there? 5i. Good. And that would be my answer. All right, let's do one more of these. These are pretty basic. Let's do negative 2 minus I, and then let's subtract 5i. Okay? Even if you didn't know what I was, you could just do this as combining like terms. Okay? So here, negative 2, nothing goes with negative 2. There's no real parts that can go with it, so it's just negative 2. And then I get negative I minus 5i. What is that? Negative 6i. Perfect. That's it. Okay, let's move on to number 3. Now we're going to take these complex numbers and we're going to multiply them. Oh, it's warm in here now, isn't it? No? It's gross. Okay, let's multiply them. Here we go. These are tricky. These are tricky. The thing you need to remember about multiplying is this. When you take I times I, what do you get? I squared, which is negative 1. Okay? So you can't think of it as just a variable. It's not a variable, it's a number. You can't think of it x times x is x squared, and we leave it. But this is I times I is I squared, which is negative 1. Okay? So knowing that, let's do this. 2i times 5i. I have a positive number 2i times a positive number 5i. I'm going to multiply those together, and I get 2 times 5 is 10. I times I is I squared. So this is just negative 10. And so this broke every rule that you've ever learned. A positive times a positive is a positive. It's not. Look at it. Positive times positive is a negative. So if anyone ever says, well, always, nope. In real numbers, yes. Complex? No. So it makes them so complex. All right, let's do another one. Oh, by the way, is anyone lost how we got from here to here? I squared is -1. So all I did was do 10 times -1, and that's equal to -10. Okay, let's try another one. How about this one? 4i squared. 4i squared. Now to take 4i, which is an imaginary number, and we're going to multiply it times itself, we're going to square 4i. So 4i times 4i is 16i squared, which is -16. You just squared a number, and it came out to be negative. I mean, you should be really excited right now. Like, whoa, I've never done that before. No, this is so fun. I know. I remember learning these when I was your age, and I hated them too. Okay, but I love them now. 3i times -5 plus 2i. Okay, so now I'm going to distribute. See how we're doing all the algebra stuff with these? It's so fun. So take that 3i and distribute it into your binomial here. And you get 3i times -5 is -15i. And then 3i times 2i is 6i squared. And now we need to clean this up. Okay? Never ever leave I squares or any powers of I in any of your answers. It'll get marked wrong. Okay? I squared is -1. So this is -15i plus 6 times -1, which I write as -6 minus 15i. Always try to remember to write the real part first and the imaginary part second. Okay? All right. I was going to say something. Oh, someone in my other class was like, well, then what's I cubed? And what's I to the 4th? Right? And you think of all these powers of I. Well, if I had I cubed, what's I cubed? No, you weren't thinking that? No? I cubed. Oh, that's my freshman. I cubed is I squared times I. Do you agree with that? What I do when I have a big power of I break it down into its squares, because I squared is what? -1. So I cubed is really -I. And Samuel's asleep now. He's so tired. Keep your eyes awake. Okay, eyes open. How do you keep your eyes awake? All right, let's do some more multiplying. What's that I to the 4th? It's 1. Bobby knew that, you guys. Okay. I to the 4th is I squared times I squared, which is -1 times -1, which is +1. So good, right? No one cares. Okay. All right, letter D. Here we go. You girls, you're laughing. I love it. 4 plus 3i. We've missed you. You guys were both absent on the same day, though. That's a little tricky.
Well, we were on a college tour.
Oh, together. Oh, okay.
And then I got sick, and we slept in the same sleeping bag, so then I got Camden sick.
Same sleeping bag, huh? That's
Same
weird.
dorm, but then and there's
And you guys all got sick there?
yeah. Well, I was sick when we left, and I got her sick.
Oh, what college was this?
Quite lonely.
Oh, yes, San Diego. Nice. Okay, here we go. Finally, we're going to FOIL now. Were you hoping we would FOIL? Yes, you were. I know. Back when you were adding and subtracting, you're like, can we just FOIL? Yes, we can. So this is a multiplication problem. We're going to take a complex number times another complex number, and then we're going to get a complex number. So here we go. You ready to FOIL it out? Q, are you ready? Don't leave me. Don't leave me hanging here. All right, 4 times -1 is -4. That's first. Outside gives me -8i. Inside is -3i. And last is -6i squared. Please show this work, okay? I need to see it. All right. Oh, there's Benny. He's so cute. There he is. You see him? Binomial Benny. Okay. Anyways, so now, this right here, this -6i squared, what is that? It's +6, isn't it? +6, okay? So make sure you change that. And now let's combine our like terms. I have -4 plus 6 is 2. And negative 8i minus 3i is negative 11i. So good, right? Yeah, the main thing to know on these is make sure that anytime you see an I squared, you replace it with negative 1. That's the most important part. Okay, let's do one more of these, which is going to lead us into division. Now, sometimes you get some special ones. I'll show you. Negative 4 plus 5i times negative 4 minus 5i. Now these two binomials, these two complex numbers look exactly the same, except the only thing that's different is the middle term, or the middle sign. This is a plus and that's a minus. Otherwise, they're the same. These are special. These have a name we're going to talk about in just a minute. Let's FOIL this out and see why this is so special. Okay? Here we go. I'll do this one in green. Negative 4 times negative 4 is 16. Outside gives me positive 20i. Inside gives me negative 20i. Oh, see what's going to happen there? Not yet. And then I get negative 25i squared. Okay, here's what makes these so special. First of all, your i's cancel out. They're gone. And this, yes, what is this over here? This is negative 1 times negative 25 is positive 25. And so what I get is 16 plus 25 equals what? 41? 41. So I took two complex numbers and I multiplied them together and I got a real number. Isn't that exciting? Those are special. Okay? And those are so special they actually named them something. Those are called, ooh, let me switch back to this color. Those are called conjugates. They're called complex conjugates, or we could just shorten it and say they're called conjugates. And conjugates look like this. If you have a plus bi, and you multiply this times a minus bi, what happens is you will get every single time a squared plus b squared, and there will be no i's at all. You get a real number, a squared plus b squared. And you're probably thinking, why is that so great, right? Well, we're going to need that in a minute. Okay, so let's see if you can do the shortcut. Let's say I have 3 minus 4i times 3 plus 4i. Let's find out what the answer is here. 3 minus 4i times 3 plus 4i. Well, the shortcut says to take a squared. Well, what's a? A is 3. 3 squared. Plus b squared. Well, what's b? B is negative 4 or positive 4. Doesn't matter. And when I square this out, I get 9 plus 16 equals 25. Okay? That's the shortcut. Someone in my other class, they had some interesting insights today. They said, does that come from the Pythagorean theorem? 3, 4, 5? So good, and it does. It does. I know. Was anyone else thinking that? Yes, okay. Pythagorean triples, 3, 4, 5? 3 squared plus 4 squared equals 5 squared? She does. Yes, she does. She's getting 100%. 100. Okay, now, knowing that, we're going to now use the conjugates to divide. What number am I on? 4? Number 4. Okay, so we add, we subtract, we multiply, and now we divide. Dividing complex numbers, no bueno. Not fun at all. Really bad. Really bad stuff coming up. Okay? I'm going to be completely honest with you. It's really bad. You know how, like, when we had something like this, and we weren't allowed to leave it like that? Okay? That's going to be the same with complex numbers. You're not allowed to leave an I in the denominator. It's illegal in math world. Just like we can't leave a radical in the denominator, you can't leave I in the denominator. So what we do in order to divide is we're going to multiply by the conjugate of the denominator. Okay? That's the trick denominator. Because when we multiply conjugates, we won't have an imaginary number anymore, a complex number. We'll get a real number. That's our goal. All right, I've got 3 of these. Are you wondering when this is going to end?
Yes.
It's not. 9 plus 12i divided by 3i. Okay. We're going to take this complex number, 9 plus 3i, and divide it by the imaginary number, 3i. Now, in order to do that, you can't just go, oh, 3i is going to go into 9 and 3i goes into 12i. You can't do it that way. What you are going to do is you're going to do it like you did for radicals, is you're going to multiply by the conjugate of the denominator. In this case, we're going to multiply by negative 3i. You could multiply by positive 3i, but multiplying by negative 3i is actually better. I'll show you why. See conjugates? See how that part right here changes from positive to negative? Curtis?
Yeah.
He's not in here.
Curtis.
Oh, I thought you were talking about Curtis, the other Curtis,
Yeah.
Walhoff, right? That.
Calculator.
What? No, he's doing imaginary numbers. He can't miss this. Why are you shushing me? All right, so let's go ahead and we're going to multiply. So we're going to multiply the numerator. When we do that, we need to distribute and get negative 27i minus 36i squared. And in the denominator, I get negative 9i squared. And there are other ways to do this. Bobby's right. I didn't need to multiply by 3, but that's okay. I just wanted to show you that you can do this every time. All right, so up top I get, 36. This is positive 36 minus 27i. And on the bottom, I get positive 9. Okay? And then last thing we have to reduce. So 9 goes into 36 4 times. And 9 goes into 27 3 times. There it is. My favorite complex number. 4 minus 3i or 4 plus 3i or 3 plus 4i or 4. Yeah, all of those variations. Okay. All right, let's do, we got 2 more of these. Suppose I have 5 minus 2i over 3 plus 4i. You're going to really hate these. Not because they're difficult, just because they're time consuming. Okay, what you're going to do is you have to multiply top and bottom by the conjugate. That's how you divide complex numbers. So as you can see, you're going to have to FOIL twice. That's why people don't, I know, that's a heavy sigh again. That's why people don't like these, because it's so much work for really nothing. No, I'm just kidding. Okay, here we go. But the bottom has a shortcut, okay? Just remember the shortcut. So let's do the top. Here we go. We're going to FOIL it out. So you want to try it? You want to try to FOIL? No? Okay. All right, 5 times 3 is 15. Okay, so I'm going here. Outside gives me negative 20i. Inside gives me negative 6i. And then finally I get positive 8i squared. Okay, I'm going to fix that in a minute. Just leave it. This is what I mean by showing work. And then on the bottom, I can use my shortcut. And my shortcut says to do 3 squared plus 4 squared. Don't you love that shortcut? You love it. And it works only for conjugates. 3 squared plus 4 squared. Okay, so let's fix everything. Are you ready? This 8i squared is what? Negative 8. So that's negative 8. So I have 15 minus 8 is 7. And then here I have negative 20i and negative 6i gives me negative 26i. And this is all over what? 25? I think I did this one wrong earlier. Maybe. And that's it. You're like, how is that done? It is done. This is actually a complex number. It's 7/25 minus 26/25 I. Gross, right? Yeah, that's really bad. Okay, do you want to see one more of those, or do you think that's enough for you for that one? You think it's enough? You're just done. Okay, and then I have one last part. 4 more problems to go. Look at it, it's only that time. I've only been talking for 30 minutes. It's a lot though, huh? It's like it's more of a quality instead of the quantity that we do. All right. Like having girlfriends. You should always have the quality over the quantity. Okay, letter C. It's true. Or friends. Friends in general, right? Quality over quantity. Complex solutions.
Variety.
Oh, you like variety. I'm telling your girlfriend you said that. Oh, did you hear that? Ha. Q said that. Yeah, okay, here we go. There's a bus, and then I just threw you under it. It was pretty sweet. All right, so complex solutions. What we're going to do is we're going to solve just like your quiz that you just took, okay? A lot of you guys did a really good job. We're not going to do all 5 ways to solve a quadratic with complex. We're only going to do 2 of the ways. So the first one is this. What are we on, number 5? 6? 5? I don't know. Nick, do you know? No, you're done. Okay. All right, number 6 or 5, whatever it is. We're going to solve these by finding square roots. Now, finding square roots. You're going to be okay with this if you did okay yesterday on the quiz, right? Did you do okay on these? These were numbers. What were they on the quiz? I don't know. They're right there in the middle. Finding square roots. It's the ones that only have an x squared term. So here's what it is. We're going to do 2 of them. Suppose you have 3x squared plus 75 equals 0. Okay? Now you get to a problem like this, and you're like, all right, solve by finding square roots. What's the first thing you do? Perfect. Subtract 75. Kendall's got it. Subtract 75 over to the other side. Second thing you do. Divide by 3. Yeah. So divide both sides by 3, you get negative 25. Okay. At this point, you're going to take the plus and minus square root of negative 25. As of today, you're allowed to do that. Yesterday, you couldn't do this problem. Today, you can. And the answer is what? Plus and minus 5i. Those are your 2 solutions. Okay? 5i goes into here, and you end up getting negative 75 plus 75 is 0. Those are the only 2 things that would be answers to this solution, or solutions to this problem. All right, try another one. B. 2x squared plus 36 equals 0. You want to try this one? Yeah, you try. You try. You got this. Solve by finding square roots, okay? If you get stuck at the last step, just stop there. At least do the first 2 parts, right? The subtraction and the division. You got that part. Oh, and 36 divided by 2 is 18. So, negative 18. If that negative's bothering you, don't let it. It's not that big a deal. You subtracted 36. You divide by 2. X squared equals negative 18. Take the plus and minus square root. But you cannot leave it like that. 2 things you can't leave in radicals. You can't leave a negative symbol, and you can't leave any perfect squares. So negative 18 is negative 9 times 2. And what's the square root of negative 9? 3i rad 2. Those are your 2 solutions. You got that? Pretty good? Yeah, I saw some head nods like, yeah. Wow. You guys really hate this, don't you? Is it because I like it so much? No, you're just trying to ruin my day? Great, thanks. Appreciate it. All right, number 7. Number 7. Do you ever do that? Someone's in such a good mood and you just try to ruin it? That's what you guys are doing to me. Thanks a lot. All right, last one. Just kidding. Quadratic formula. No, you guys are the best. You're my favorite class, 4th period. Oh, wait. This is 6th. Quadratic formula. Sometimes I'll say that to my kids. I'm like, you're my favorite. Yeah. And then I'll go tell the other one, like, no, she said I'm her favorite. Because I do. I tell them both. Neither one of them are. Okay, here we go. Quadratic formula. 2 more. We're done. We're going to solve using quadratic formula. And in this case, you can't tell if you're going to get complex solutions. You don't know that yet until you do it. Okay? Do you remember the discriminant? And when we got b squared minus 4ac was a negative number, there were no real solutions. I was telling you the truth. There's no real solutions, but there's two complex solutions. I didn't tell you that because you weren't ready yet. Now you're ready. You can know. Here we go. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2 times a. Okay. So, what I get, see the discriminant? The discriminant is this number inside of the radical. That happens to be what? Negative 23. So you say, oh, there's no real solutions. You're right. The solutions I'm going to get are not real. I get square root of negative 23 over 6, which is 1 plus or minus I rad 23 over 6. I get 2 complex solutions. They're not real. Okay? Remember the 3 things? You don't have to write this down, but let's recall. 2 real solutions. 1 real solution, if it hits right there. Okay? Oops, just 1. And then this one was no real solutions. But this one right here has 2 complex solutions. And by the way, complex answers, complex solutions to polynomial equations like this, they always come in pairs. They're like girls who go on a college visit or girls who go to the bathroom, right? They're always going in pairs. Let's go, right? That's what complex numbers do. They have to have a friend with them, which is better. Life's better. Like me and my sister, we're twins. She's so pretty. All right, letter B. Here we go. That's a joke. X squared minus 4x plus 5 equals 0. Last one. Are you going to try it? Or am I doing this with you? You want to try it? You try it. Let's see. Pause the video. Did you get some complex solutions? X is equal to negative b plus or minus square root b squared 4ac all over 2a. Okay. Now, you know how to plug this in. Now let's simplify. This inside of here is 16 minus 20. You can do that on your calculator if you need to. But that's equal to negative 4. Ooh, negative 4. Aren't you guys so excited you were never allowed to take the square root of negative 4 till today? Yes. You're like, take me back to when math was easy. 4 plus or minus 2i over 2. And then simplify. 2 goes into 4 twice. 2 goes into 2 once. Those are your 2 answers. 2 plus I and 2 minus I. Did anyone get that before I did? Good. Ooh, about 7 or 8 of them did. Okay.